Okay, fine. Let's proceed. So what have we planned for today? So today we will look into 2D lists. Okay, and we wind up with list actually, and you get to understand why we spent, I mean, enough time dealing with lists. Because you see, as the class progresses, when we start with our ML, machine learning, and maybe like advanced concepts, okay, and data science stuff, you will discover that many a times we need to kind of work with this and work mostly with list comprehensions. Okay, list comprehension, we treated that yesterday. All right, okay. And so as a matter of fact, we will go this way. Okay, so this is first thing, printing two-dimensional list. Thank you. And then we look at use of list comprehension. Okay, some example. Okay, I'm going to print a 2D list and then I'll use list comprehension in one line of code. And you might actually need to flatten a list. So if I'm in 2D list, given a 2D list, can you actually flatten this? All right. So why do we need to flatten? Think of a 2D list as a box or a cube, okay, like this, in which, anyway, this is 3D, okay, in which I need to flatten this, maybe it look like this, fine. So why do I need to do that actually? All right. So, and we get into examples and try to look at while loop. The essence is actually to look at what? This guy, infinite loop, infinite loop. We always create this loop. We always create it knowingly or unknowingly. Okay, if you create something, that means you did it purposely. So at times you see, you might, try to check a condition, okay, but you discover that that condition will never terminate. And definitely there will be some homework for you, okay? All right. So I don't want to waste much of our time. I want us to just start immediately. Fine, let's start. Okay, so what have you planned? I'm going to scribble something. I just believe it will be visible. This is our day 9. Okay, just in case if you are joining us, day 8, this was what we did actually, right? We looked at, again, we continued with list, looked at some of the stuff there, like the modules that are present in the list, the choice, the sample, the shuffle, and other stuff, right? And things like that. Okay, so don't see this. This is my Java class. Now, today we'll be continuing with what? You guessed it, to the list. So this welcome to day 9 of, day 9 of 100. So we're going to look into two-dimensional lists. Fine. Okay, so let's take example right away to avoid taking much of your time. So one of the things you notice is there will be a time in which you might want to, create a two-dimensional list. So you might think, what is an example? So say a case study is, your computer screen, right? Images, let's consider this to be your display unit. Okay, so images in this display unit are in form of what? Pixels, right? So, and those pixels, they have what? Coordinates, right? So let's say there is a point here. Okay, let me draw some smiley. Okay, smiley face. I believe I'm able to get this. So this is a smiley face, and this smiley face, they have coordinates, right? So this coordinate is what? 2, 3, right? So you see, if I have 2, 3, maybe like I have 2, 6, and maybe I have here maybe like 4, 4, and here maybe I have 4, 8. Okay, 6, something like this. Actually, I can squiggle this stuff, okay, into a two-dimensional array, such that now you might say, no, sir, see, you can actually write it as 1D, okay, considering each of them, okay. But have you not seen tuple inside a list? We saw that tuple inside a list. We saw that, right? So we had a list, and inside that we had, say, 1, 2, okay, and then we have 3, 4, something like this, okay. So this was like tuple inside a list. Now, can we have list inside a list? Yes, we saw that. So, but when we have list inside a list, we actually call it a 2D list. So this is your tuple inside a list. Inside a list. So if you have a list inside a list, so we call it what? 2D list. And we've seen that, but we did not call it 2D list. And why is it that is this time that I'm actually trying to separate it? Okay, so I'm going to say again 1, 2. This I have something because I'm going to use this example. Fine. So if you see, you can write it like this. Okay, then you have 3, comma 4, comma 5. Remember, we are using square braces or brackets. Then you have 6, comma 7, 3, 4, 5, 6, 7. Okay, okay. 3, 1, 2, 3, 4, 5, 6. So I repeated that. But you got the concept, right? 6, 7, 8. Because I'm thinking, why am I not able to count till 9? I repeated this 3 twice. So you got the concept. Now, this list, okay, inside the list, you might not see it as a 2D list. Hence, we rewrite it as this. So we rewrite as what? I'm going to repeat the same thing now, but now it's going to make sense, okay? So here I have 1, 2, 3. Okay, then comma, I'll write like this, 4, 5, 6, comma. Then I have, okay, I'll show the screen. Then I have here 7, 8, 9. Then I can close it like this. You got the point now? So you can think like, okay, this is the opening brace, okay, square bracket, this is the closing. Fine, okay? Hence, and these are the other ones. Fine, you got it. So you can now think that this is a 2D. So you now see this finds its useful application, say maybe when you start creating games, okay? Okay, and like I've told you about the concept of pixels, you can actually represent it like that, okay? So these are 1D, but inside this you have bigger one, okay? So inside this you have bigger one. So that's the concept. Fine. So how does the index start from now? Because index will start from row, obviously index start from row and columns, right? So if you look at this now, so you can say here it is a 3 by 3 what? 3 by 3 array, okay? Or it's a 3 by 3 list. So that means it is a two-dimensional list. Fine? Fine. Now, what is this first three? This first three refers to your rows, number of rows, and the last three refers to your number of columns. Got it? Fine. Hence, instead of us using I and J, okay, so we will use R and C as rows and columns. So if you look at it this way, let's say this is what? Consider this to be a list which contains this. Fine. Hence, if I want to iterate through this list, I will say L of what? Subset of what? R. Okay, and then subset of C, right, where this stands for rows and that stands for columns. Got it? Fine. Now, one of the things you might need to do, okay, most times we don't know the length of this. Remember, you have the len function to know, okay? So if you just run len on this, okay, what do you think it will yield? We will try all these things practically, okay? So I want you to feed your curiosity for now. Will it yield 9? Will it yield what? Okay? Now, if you want to iterate this, and I'm going to make that mistake now because this is what most of us usually do. So if you want to go through this and print every element in the list, say example, write a program. This is first example that prints, okay, all elements or all items in a 2D list. So take this as an example. So what do you do actually? Can anybody tell me? So you see, we've got into the concepts of looping actually without, without dedicating a different chapter on that. So you've seen we've used lots of for loops and if loops, okay? But I dedicated a session now, I'm going to dedicate a session to while loops, fine? Now let's see this. Now there are what? You have rows and columns. Hence you can use what? Two loops, right? So the first one we run through what? The rows. So they say for R rows, right? For rows in range. You remember the range function? In case if you don't know, please see our previous tutorials. In range of, please listen, what is the range? 3. Okay? Now colon. This will go through the rows. So it's like this. Let's say you come here, this goes this way, then this will take here. So if I have R1C1, yes, so this is like I can call it R11, right? R12, R13, okay, R21, R22, and R23. You got the point? R31, R32, and R33, okay? So what I mean here is, okay, this is this row, maybe third row and second column. That's what I meant, third row and third column. So that means this we iterate through the rows and the other one we iterate through the columns. Remember, you have to nest these for loops. So for cos in what? Range of what? Range of 3. Fine. Take care. Now, what do you do? So you have to print what now? Print. L, that is the list, right? Of what are. Please remember it is square braces. Okay, we are going to demo it and see. Fine. Then you might actually prettify it. Sorry, you can separate it by using this end line something. Okay. Now, and then that's it. Okay. Now, please listen. The funny part is what you're going to get here is the C, okay? This will hold true. What happens when you move this print to this side? Okay, I always tell you guys to please try this, okay, and repeat the same thing. Or what happens if you shift it further and keep the print here? Okay, please try all these things. Okay, fine. So this is the first thing we want to do. Okay, and another time we might actually use this. So I want to introduce this because we might be using it in the near future. It's called pretty print, PPRINT. How many of you have encountered this before? So it's actually a model. Is a model. So I told you how to find that, right? You can quickly go to help and just type help on pprint. Okay, so let's see. Wait, I don't want to waste so much time because I have lots of demo. Okay, so pprint, you might actually use it to format your print statement, okay, or to format the output of your code. So this stands for pretty print. Fine, and keep this in mind because it's present in one module called from pprint only. You have to import. It's so funny. Import pprint. Okay, it's not like from math import square root. Okay, so pprint is the model, so you're going to import this function also from that. Fine. So this will give you a kind of a nice output. Okay, so making sure that this is formatted. So I said something, right, that I'm going to give you a kind of example on list comprehension, right? So let's go to list comprehension. I believe this is clear, right? Fine. You have a 2D list. You have iterated through that 2D list. And that 2D list looks like what? A list inside a list, as we had tuple inside a list here. Okay? A tuple inside a list and list inside a list. Fine. Now we rewrote it properly to look like a two-dimensional list. Fine. And we've seen the use cases, right? Especially in your pixels, and maybe like most times if you want to kind of design a game in which like you have to iterate through some sequences of stuff. So we are going to do that. We'll be developing such applications soon. Okay? Now, this is fine. What we should do next is this. Let's use the concept of what? Concept of list comprehension. I touched this yesterday, but let's look at that. Concept of list comprehension. Now, okay. Now, I'm going to use a kind of an example, all right? Because I believe when I write, you try to follow, okay? So let's say the same list. Don't forget the same list. So I'm going to say for R, I'm going to use R now for rows in range, okay? In the range of what? 3, fine. Then again for what? C for columns in range of what? The same thing, right? 3 by 3, fine. Now, please look here. Let's say I want to count. So the intention is to count all even numbers in that list. In case if you've forgotten, the list contains items from 1 to 9. So how many even numbers are here? Anybody? How many even numbers are here? Between 1 to 9, how many even numbers? 4, right? So those even numbers are 2, 4, 6, 8. And now you know how to write a program that will check if a number is even or odd, right? Fine. So what we do now, we now say if, right, in that list, yes, after I have gone through the rows and columns, now you know how to read that, yes? Any of them, if I take the first one, like R1, like R, you got my point, 1, 1, that means first row, first column. If I take the element, fine, and divide it by 2, and if the remainder is exactly equal to 0, remember the intention is to count, right? Fine. That means I need to set a variable called count. Set it to what? 0. Initially, this count will be empty. Now, if this count is empty, I have iterated through this, and I have performed this modulus operation, in case if you've forgotten, okay, modulus. So, after I perform this now, what do I do? If I get that, say, the first one is to take 1. If I divide it, it's equal to 0. No, so it will not increment count. It will not increment count. Get to second one, 2. 2, if I divide it by 2, will I get 0? Yes, so count becomes increased, which is what? Count plus 1. Okay? Sign. Or you can actually use this shorthand operator count, C-O-U-N-T, count plus count plus equal 1. Okay, so this is your shorthand assignment operator. Fine. So stick to this first. So once this is done, right? So you now need to print what now? You can now say, once this is done, you now say print what? Count. And it's going to print what? 4. Now, the next thing I want you to do, you see this count, I place it under this. Try to place it under here. Okay, this print, or try to place it under here and see what it's going to get. We demo this soon. Okay, fine. Now, is this list comprehension? No, this is not list comprehension. So what is list comprehension here? You see from here, right? Okay, we can write it in one line of code, but it will look so funny. I mean, even it will look so funny now. Just see here. So using list comprehension, I'm going to say count, okay, equal, yes. Now, since I don't want to, there's this inbuilt function called sum, right? So I can use it, sum, because I want to know how many of them. You got the point? Fine. Instead of this perform summation, I hope you get that. So instead of this, now I'm going to replace it as sum of what? Now I'll say this one for r in what? Range of 3. So that means I'm going to move this r in range of 3, as you can see there, r in range of 3. Okay. Now I'm going to count this. Then again, it's not stopping there. 4 columns in range of 3. In range of 3. I'm going to show this also and make the code available also for you guys, no problem. Now you now say if, yes, now you put this condition, L of what? R and C is exactly, sorry, divided by 2 is exactly equal to 0. This is where it ends, okay? Now this is the same one line, so you can actually wrap it around the print statement. Got the point? Fine. So, but you see, it might look difficult to understand, but this is the concept of your list comprehension. Okay. Fine. All right. So some of you requested for the code, okay, and I will definitely make it available. So in tomorrow's class, we will go through GitHubs, okay, GitHub, and I know for sure many of you knows about it, but I think, sorry, some of you knows about GitHub, and maybe a majority of you, a handful of you, not majority, might not be knowing about it. So you will see me perform this in live session tomorrow and push all the codes on GitHub so that you just download from there. Okay, fine. So you download, so we say the first 10 days of our challenge, I'm going to push out some of the stuff, okay, and even this handwritten note also, if that is going to be of help to you, okay, but it will not make sense if you're not following the tutorial, the live lecture. Fine. So I push that out and then you get all the codes. Okay. Again, on the next 10 day, again, I'm pushing out another code. Okay. Or I make it every five days now. So remind me, guys, I'm going to do this tomorrow. Fine. So you got the concept, right? You got the concept of list comprehension. Okay. Now, after this, what again do you actually want to do? Okay. So I think for now we can try to demo this before I move to the next thing which I have for you. All right. So what is it that I plan doing? I think we'll be looking into loops. Yes, I hope you remember, right? So let's get to this before we look into loops. Okay. So I'm going to open this now and then I'll maximize this one screen at a time. So look here, D2D list, printing 2D list, use of list comprehension. Oh yeah, flattening of list. Okay. And then some example. Okay, so I said I'm going to show you how you flatten a list. Okay, so I better do that hands-on instead of just explaining. Okay, fine. So let's get there quickly and then we will start with our stuff. Okay, so the question is, why do you even need to flatten a list? Like, why do you need to flatten a list? I don't know. You should find out. Let's start. Okay, so as always, I try keeping these things together. Okay, here you have all the programs. Okay, and I'm going to maximize it here. So I'll start running them one after the other. So I'm going to comment this out. So this is an example, the example which I just gave you now. Okay, is looking at us here. So this is the example and we have it here and we iterate through this, fine. And I'm going to run this now, but before that, I have to comment these guys out. Let me ensure that everything is commented out. Oh, no. So I will comment this guy out as well. Oh, sorry. Simplest way. Oh, yes, I got the problem here. Fine. Okay. So this is done. And this is exactly what I just showed you now. And let's run it. F5, done. Okay. Now, what did you notice? This printed this list, right? Fine. So you can actually say, call this and find the length of that, right? It's called L. What's the length? So it's 3. Now, why did it not give us 9? Why, guys? So it is a two-dimensional list. So this is one of the cases in which you might want to flatten this. So when I flatten this now, I'm going to get the length is 9. Okay. But for now, it is a 3 by 3 matrix. Okay, sorry, I don't want to say matrix, but yes, a two-dimensional list of 3 by 3. And if you know the concept of your matrices, it's the same thing here, right? Now, but there is something that is very common. Okay, let's say we don't know how much the length is, and maybe we think it is 10. Please look here. We think it is 9, sorry. Okay, we think it is 9, and then we go and check here, and we say 9, right? Fine. Now, there will be an error, and this will be an index out of bound error. Hence, you should know how to check the length of this. Fine, you see here. So this is index out of bound, but first thing it's printed this. So did you see in Python 3.10, actually it's giving you hints. My brother, look at this properly. First 3 is printed, hence this might be a 3 by 3 matrix. Okay, so you go and change it, and then the error will disappear. Fine. Got it. So this is what we have, okay, and you can actually see that works best when you know the length of that. So I'm going to comment this guy out now, and let's proceed. Fine. Okay, so this is done, and let's look at the next one, the next example. Okay, sorry, I'm not done actually. I wanted to show you something, right? So this was what we did. Let me just run this and keep the output there. Okay, so you understand what I'm going to do next. Now this is fine. Okay, now what did I ask you? I said try doing something here, okay, using this p print. Okay, so we have to import it, okay, and then we import this as well. Okay, fine. But before we prettify this, let's run this and I'll show you the next example. Now what did you notice? Did you see how it's printed? Now you might think that this is flattened. It's not actually. This was kind of list inside a list. Did you get this? Exactly. So many a times when you work with some projects, really data science on data science projects, you might want to print it like this, and you get confused now, right? So is this what do I call this? An array inside an array, a list inside a list, a 2D list? But with this, you can actually get it. So this will tell you kind of the shape of that. I don't want to use the shape now because that is a entirely different thing. What I wanted you to do is I'm going to comment this one out, and I want you to try something here. Okay, I believe many of you are running this doing this with me. So let me push this till here. Okay, I hope you're able to follow. By the way, just this prints just an empty space, okay, in between them. Now, let me run this. Now you see here, expected indentation. Okay, this guy will not allow me, but yeah, that's fine. So what if I print it at the, let me see if this will give me indentation error, please. No, it's not going. Okay, so this will help you to correct it immediately. Okay, so I'm going to do another case in which it will not allow us, only at execution we will get the error. Fine. Now this is done. Next thing, what I wanted to do was this, to use list comprehension, right? Which we just said now. So comment out the remaining. Okay, and this is what we'll have to do in list comprehension. Okay. For now, look at the same example, right? And you know the concept of count now, and this was what I just explained, okay? Without list comprehension, this I commented out is your list comprehension. Don't forget, this is your list comprehension. Now, prior to that, let's run this and see. Okay, now you see it said 4. Okay, in case if you didn't get that, I'm going to run it quickly. Fine, and you got the, you knew how it was 4, right? All the even numbers between 1 to 9, there are 4 of them, 2, 4, 6, 8. Fine. So I'll comment this out. Okay, sorry, this count, I'm not going to print this count here. I'll comment it out. Okay, and I'm going to print from here. Now look here. Okay, please look here. Again, sorry, I'm counting it, so this is the same thing. Okay, you got the point? You got what I'm trying to say? Because it's going to repeat this twice. Okay, so instead of that, I can comment this one out. Okay, and just run this. You got the point? So comment the entire thing out here. So what I want to do was this. This is out, this is out, that is out. Okay, and then my count is set to 0 and the list is there. Fine, and then count is that, so I have to print this count, otherwise it won't print anything. You got the point? You can also wrap this around what count print statement. Okay, so I counted it and then I just print it. Fine. Okay, so you see again we got 4. I hope you understood what happened here. This was the 4 I was talking about. Fine. Okay, so this concept is clear. Okay, so I'm gonna comment this out and then I move to the next one. Okay, so why do you need to flatten this list? Okay, so in that case, let me quickly remove this guy. Fine. Okay, no. I have to close this there, and then I will, yes, all these ones are open. Why? Okay, 1 minute. So I try to close this here. Yes. All right. So you see, you might need to flatten this. Okay. So in such a way that, but before we flatten it, okay, let's just understand why we want to do this. Okay. So why do you actually want to flatten this? Let's say you want to return it as a one-dimensional array. Okay, so I said here this is very important. You can actually wrap it around the print statement, and we do that we do it in both cases. So look here, there is a problem with this. That was why I commented this out. So why do you want to flatten this? I want to return this as a one-dimensional array. Okay, so if you are asked to write a program that returns a 2D array into a one-dimensional array, note that they are asking you to flatten a two-dimensional array. So I'm going to flatten it and stretch it as a one-dimensional array, as if I use pretty print, but it's not the same. I'm going to get it like 1, 2, like that. Now, if I run this, I'm going to get a different output, and I'll tell you what that is actually. So if you see here, did you see this? This was like you use pretty print. Do you remember? We just did that in a couple of minutes ago. This was as if I used pretty print. You got the point. So using pretty print will give me the same thing. I did not flatten it. But you might say, yes, this was what I needed. So I'm going to leave this now there, and I'm going to do something else. Okay. So after this now, look here, please. I'm going to run the same program, but here I'm going to wrap it around print statement. Okay. So I'm going to wrap this around print statement. Remember to close it. Fine. Now, once I do this now, you will see something else. Remember, this was the first one, right? This will like similar to pretty print. Sorry. I can see my keyboard. Okay, similar to what? To pretty print. PPRINT. Fine. PPRINT. Okay. Now I will run this now. Okay. Sorry. F5. Okay. Now did you notice something here? Please pay attention. The previous one was pretty printed. Now this one was this. Okay. Now this is what I needed. Now you might say, okay, why did I print this again? I don't know why I printed it again. So I can comment this guy out. I just printed it to show you the comparison, right? Fine. So I'm commenting it out now, and then I will just run this so you see. Okay. So this is purely flattened. Now you see the difference. So a flattened 2D list will look like what? A 1D array, and not looking like a 2D array. Got the concept? Fine, let's proceed. Next. So what I said is this. On this note, I want you to look at your homework. Okay. So this homework, based on whatever you have learned, can you write a program that asks a user to enter some text and count how many articles are in that text? Example. Looking at this program, please write a program that asks the user to enter some text and count how many articles are in that text. Now, what do you mean, sir? What is an article? You have seen it. Definite article, a and the and stuff. Okay. So let's take demo this. Okay. I need what do you call it? I need a text file. I say, this is my sorrow, a beautiful city in South India, and the cleanest in India. Now, how many articles are here? So the first one is called, I didn't use the, but you can see a. Okay, in, I don't know in, and actually is an article. So the is an article. So if you count here, I don't know whether is an article. So you should ask Google, please. Ask Google about what? Definite, maybe if you want definite articles. I know definite is a and the, right? Like that. So I don't know whether in and is also an article. I don't know. So you ask Google about what? An articles in English. Fine. Such that you have to capture them and store it in a list. Okay, and now check whether whatever you are going to iterate through is contained in that list. If it's contained in that list, if it's exactly equal to say a, e, whatever, sorry, is, and, in, whatever then you have to increment it. Similar to the word count program which I just showed you, right? So, and then you count how many of them. Okay, fine. The next question. You ask a user to enter a sentence and print the third word in that sentence. Example. Look at this sentence, right? This is Mysore, a beautiful city in South India. Let's say this stopped here. I stopped here. I don't want to make complex sentences, compound sentences. Then the next one we start with the. So which is the third word? I want you to print Mysore. You know what to do. So indexing, you can start from 0, 1. For this, you definitely have to use what? Not two-dimensional array. Okay. So you need to find where it is. Okay. And remember, you have to accept this from the user. Can you attempt that? All right. So ask a user to enter a sentence and print every third word of that sentence. Why did I repeat this twice? Sorry guys, I don't know why I repeated this twice. I think I wanted to write something else. Okay, but at least if you can do this, that also is a very good assignment. Okay, so let's move to the next one. Okay, so we have finally gotten to loops, and I think I will demo it with an example because we have seen lots of examples actually using for loops. So let's go to while loops. Okay, now, do you remember our temperature assignment, which I said you write a program that prompts the user to enter a temperature, right? Yes? And now a temperature in centigrade. Now, the question is centigrade called as Celsius? You are confusing us, sir. I asked Google, and Google said, what am I looking for? Google says that centigrade is known as Celsius. You can actually verify that. So Celsius, Celsius or CIUS, I don't even know. Celsius is aka centigrade. So in case if I use them interchangeably, please verify from Google. All right. So if you prompt the user enters the temperature in what? Centigrade, you convert it to Fahrenheit. So this is the formula. You remember this program, right? So, but look at the first thing, okay? I want the, see, let's say what is freezing point? I think freezing point is -4, right? Yes or no? So let's say if the user enters minus, I don't know, is it 0 degrees is -4? Yes, say if the user enters -4, okay? I will say enter a temperature, and when you enter -4, I have to quit this. Please listen. As long as, this is the concept of loops, right? So especially while loop, this program will keep prompting the user to enter a temperature until this condition is met, right? That's why it says why it is not equal to, please look here, look at the only difference here, okay? So what you did before was you just did this and you converted it to Fahrenheit, right? Now, as long as user enters a number that is not -4, keep asking them to enter a temperature and keep converting it to Fahrenheit. Hashtag. Fine, let's run this. All right, so what we get here is this, okay? Enter a temperature. Let's say we enter 100. Now, it says he converted it to Fahrenheit, which is 212. Fine. Enter another temperature, we say 50. It converted it to that, which is that. Enter a temperature, we say 4. It will not quit. Enter a temperature, we said -4, right? Now it will quit. But you see the problem here. Did you notice a problem? Okay. You didn't notice that. Fine. It also converted it. Look here. It gave me the equivalent and then only it quit. Now, whenever you see these 3 ellipses, right? Sorry, I call it ellipses. 3, what do you call it, greater than sign, okay? Or insertion operator. So when you see this now, you notice that, see, actually it has terminated, right? But let me look at my variable. Actually, the variable is called temp. What is the value of temp at this location, at this time? Okay, temp. Now, temp is holding -4, okay? Obviously. Now, did you notice something here? That it actually executed this. So, is this how you program? I mean, so that's why there is an improvised way or an improved version of this program, which you're going to see right away. So, the 5th one is the improved version of this, okay? So, and I want you to see this, please, quickly. Now, you see here, I'm going to use -4 as I have started using that. So, the same thing, right? Okay, please listen. I use eval and I ask you to use input. So I'm going to change this now to input, okay? So this is what we are, convert it to int, please. I'm saying input, sorry, please, okay? Because what we want to work on is this. So, and I explained this in the previous class, right? The difference between eval and int. Now, as long as this is not equal to -4, okay? I'll say enter -4 to quit, no problem. Now, please look here. What I want to do is this, okay? Once this holds true, I will say I'll print C. Please look here. Please look here. As long as the user did not enter -4, I will convert this into Fahrenheit. As immediately the user enters -4, I will come out and print thank you, see you next time. I will not evaluate this. This was the problem here. Look here. That even though the user entered -4, okay, I did not actually, I mean, why should I even calculate this? I went ahead and I calculated that. Hence, this can be called, you can call it nesting of loops. Sorry, it's a nested loop. While loop, if loop inside the while loop. I believe you got the concept. So as long as the user did not enter -4, give me the equivalent in Fahrenheit. Once the user enters -4, print this. So let's see that quickly. F5. Done. All right. So it says here enter a temperature. I'll start with 100. No problem. It will calculate. I'll ask maybe like 35. It will calculate. Now I will say 67. It will calculate. I will say 4. I will say 4. It will calculate. Now I will say -4. Now watch here. It says thank you. See you next time. Unlike the previous one, it did not calculate this. But the next thing is this. Can a temperature, okay, let me do something here, please, quickly, so that you understand what I mean. Can a temperature be greater than a particular threshold? Say, example, I entered, okay, yes, we don't know. What is the maximum temperature recorded by the sun? I think 600,000. I think they say surface temperature of the sun is 600 degrees. Okay, so this is 600 degrees Celsius or 6,000 degrees Celsius. Fine. Now, what is the maximum temperature ever recorded? I don't know. Maybe mechanical engineering students will help us. Maybe let's say that the maximum temperature is 10,000. Okay, I want you to modify this program such that the user should not go beyond the maximum temperature. I know the minimum temperature is called the sub-zero temperature, and I think it is -21.217 or 213 point something. So I can check for minimum temperature. You got my point? So I'm going to check for minimum temperature, and I want you to check for both minimum and maximum, such that when the user enters a temperature that is beyond a particular threshold, you tell the person, oh, are you in hell? Okay, this place is so hot. Okay, so when the user enters a temperature that is less than a particular threshold, you say invalid temperature, it's too less. So because of that, okay, I want you to modify this program. You got the point? Fine. All right. So modify the program so that you check for the minimum temperature. Okay. Now let's look at the next thing. Okay. So the next thing is this. Remember we worked on random guess program, word guess program. Do you remember I said you can play with your mom? You say, Ama, I finally learned how to code. Whoa, like that. You are so excited, and you tell Ama, I'm going to play a game with you. So the game I'm going to play is I'm going to ask you to guess a number, okay? And this computer will help you to check whether you got the number right. If you got the number right, the computer will tell you this is number, right? So you remember we did that before. But the thing was, every time we have to go press F5 and run it again. So for now, this is a random number between 1 and 10. And I will tell you also, there is also a little problem with this, okay? It's a little problem, there's a little problem with this program. Now, why this guess is not equal to the secret number? So I'm asking you this question. What is the secret number? I don't know. It's a random number from here. Secret number is a random number from this, from 1 to 10. Okay? Now, you remember initially we called guess to be like 5. You remember? Yes, in this program, if you actually follow the previous class. In case you've missed up this, go ahead and start from the first day so that you're able to understand what we are doing. Now, if you look at this properly, you see that I don't know what the random number will be, but there are equal chances of all of them being sampled, right? Fine. Next, as long as it's not that secret number, okay? Keep letting them guess the secret number. Finally, once they get the secret number, then you come out and say, ho ho, you finally got it. So let's run this quickly. Okay. Now, sorry, I have to clear the screen because lots of trash is there now. Now, F5. Okay. Now you see here, I start with 1. Guess the number. 2. I want to go in this way. 3, 4, 5, 6. What is the number? 7, 8, are they 9? What is this number? It has to be 10. You got the point now. So it has equal chances of being sampled. Now, I got this C at the 10th iteration, okay? So the probability of me getting it at the first instance is 1 by 10 or 10%. Fine. Now, if it is 10%, let's run this again and see whether it's going to remember 10. You got the point? So your mom is very smart. She's now like, okay, beta, I got the point now. I'm going to start with 10. You say, Ama, this is computer. She's like, but how? You said the secret number was 10. What is this, beta? You say, no, Ama. See, this is computer, ma. It's actually guessing. It's every time you run this program, it will shuffle it. Okay? Mom is like, okay, my daughter is so happy. I'm going to buy you some chocolate. Okay? Now, okay, Ama says, okay, this time I'm going to go in reverse order. 10, 9. Oh. Beta, what is the number? Mom, I don't know. Okay, tell me, don't lie. No, 8. What if, please listen here. What if mama enters 100 or 1000 or 1008? Now you see, she can enter a very large number. She can enter a very small number. Hence, I want you to give her a hint. Please listen. If she enters any number between this and that, say 1 or maybe like between say above 10, sorry, above 10 you say number too large, below 0 you say number too small. Because what if mama enters 0? Please listen. What if mama enters 0? The number is not there. 0 is not there and it has increased the time complexity. What if mama enters 11? Okay, so you have to kind of modify this to tell her that anytime she enters a number that is out of this range, you tell her number too far high. Don't give her the hint that she has to enter between 1 and 10. Don't give out. If you give out, then it becomes easy. Okay, now mama is still guessing again. She now says, okay, 7, okay, 6. Yeah, finally got it. Okay, so because initially it was 6. Okay, fine. So whenever you run this, you see it keeps changing. So now you're getting comfortable programming. So you're like, okay, fine. Whoa, you're feeling like Bahubali, right? Good. Now look at this. I want to actually to show you something that even for loops we have seen, we can actually prototype for loop like a while loop only. So while I in range of 10, so I'm going to generate 10 random numbers, right? So while I in the range of 10 print something. So let me comment this guy out quickly and then I'll show you. With a while loop and, sorry, with a for loop and with a while loop, okay? So since we are okay with for loops, it's easy, right? Fine. So you see here whether they're going to give you the same thing or different output. So 0 to 9, no problem because it's in the range of 10. So less than 10, sorry, I is less than 10 and I starts from 1. Please look here. Here you might not understand. For I in range of 10, remember the upper bound will not be considered. So it starts from 0 to 9. Now let's print it with a while loop. Okay, I'm going to comment this guy out and then I'm printing it with a while loop. Fine. Now in this while, what are we going to get now? Quickly. So we see here, we just run this. Fine. And what we see, again, we saw the same thing. Can you see that? Yes, 0 to 9. Okay. So what is the difference? Nothing is the difference only. But you see the flexibility, right? So this is very easy to use, right? But this you have to specifically state that why this condition is not true, is not met. You have to print this and increment it. Okay, fine. I hope this makes sense. Next. So we're going to look into something else. Okay. The temperature program which I just showed you, right? And I want you to now understand that there is an issue with that, okay? So the issue is, I don't know the maximum value, right? I mean the maximum temperature, okay? Like I told you, I don't know the maximum, but I know of the minimum. I actually Googled it, obviously, okay? So the maximum is what I want you to do. So you have to check. So there's something we call absolute zero temperature. So it is minus 273.15, okay? So if somebody, just imagine, somebody enters minus 300, you have to tell them, hey, that temperature is not possible. Okay, even polar bears will not survive in such temperatures. I am not sure, because I think polar bears also can survive. Okay, but yes, I don't think any human can survive in a temperature that is below minus 2 something, okay, 273 degrees. So as long as temperature is not like this, it's not less than this is the lower bound, you print it in this. I want you also to check for the upper bound. Very easy, right? A if statement, that's all. Fine. So do that, okay, and that will be your participation also. Sorry, I need to clear the entire screen. Okay, so now what am I doing? Now let's enter a temperature. Say we enter 400. This is the upper bound. I mean, I don't know the upper bound. But yes, it's there. Okay. Now this run and it just stops. That's it. You got the point? I want you also to turn this into a loop. And actually I did that here. So this just ran once and it stopped. Okay, so I'm going to repeat it again. So if I enter minus 300, okay, then this temperature is not possible and it's stopping. So again, nobody programs like this, hence you have to improvise on this program, right? So this is the improved version of that. Okay, now, and if that's the improved version, I want you to remember something. Okay, improved version, obviously, okay, you put a while in front of the temperature. Instead of an if statement, you use while, and you print this. You got the point? Easy. Let's run this quickly. And what do we get now? So let me enter, say I enter 100, no problem. Okay, that is there. And again, sorry, did I save that program? 1 minute. Which one is executing? Yes. Okay. So yes. Okay, why this is less than this? Okay, I have to print this. Okay, enter temperature. Okay, that's fine. Okay, that's fine. And 1F5, yes. Let's say I'll say 400. Sorry, 400. That's okay. It should actually prompt me. I think I didn't push this properly. Okay, I didn't nest this properly, but you got what I'm trying to say, right? 1 minute. This should prompt me to yes. Okay, I'll print this. Okay, then I'll be inside the loop unless I enter this. Okay, fine. Okay, enter a temperature in that. I will say 200. Okay, that is wrong actually, but you got what I'm trying to do, guys. Okay, so this is fine. Okay, so I want you to ensure that you repeat this n number of times. Okay, I don't know why I messed up this, but anyway, that's part of the learning. So here, the next thing I want to highlight is the infinite loop. Okay, so the famous infinite loop. Many a times you do this without knowing. Okay, you do this without knowing. Say example. Think that I want to print from 1 to 10. Please listen. From 1 to 10. I've kept this. I say I is equal to what? 0. I will now say while I is less than 10. Print I. Guys, listen now. Is 0 less than 10? Yes. So when will this become true? Will it ever increase? Did I put I plus plus or I plus 1? No. So this, I wanted, okay, just to do this until I reach this condition. Now look at what will happen. Okay. Now this will execute until I run out of memory. As you can see, it's still moving, right? It's still moving. See, how will you know? You try to highlight, so you see how it's jumping, right? Excuse me. So if this keeps happening, what you can do is just press Ctrl C. Actually, is there to keep this. Okay. In this shell prompt only is called Ctrl C only to interrupt that. Okay. So Ctrl C interrupts that. Okay. Keyboard interrupt, and that's it. Another way, the easiest way to generate this infinite loop is to use what we call what? The true statement. The simplest way. Okay. So let's I want to say I want to print welcome. Okay. So I just went and I said y true, print welcome. So this will never terminate, right? So you see here, welcome will be there on the screen continuously. Okay. And again, you can actually see that this is happening whenever you do this. Okay. So on this note, I'm done. Okay, because I said I will try to be knocking off little time in between. Okay. So let's see what we actually did today quickly, and then we wind up. Now, so let's go. All right. So what did I do? Okay. So what did we do? Not I. We did it together. Okay. So we looked at this. Check. Printing to the list. Check. Use of list comprehension. Check. Flattening a list. Check. We're almost there. Examples. Lots of examples. Check. Use of while loops. Check. Infinite loops. Check. And your assignments. Check. Okay. In case you are interested to know what the assignment was, please look at it here. Okay, so it's still there. So I'm going to maximize this. It says reload this, fine. I'll get there, and this was your assignment. Okay, your homework. Okay. Look at it here. It's still looking at us here. This is your homework. Okay, so on this note, I want to thank you so much, guys, for listening, because I know many of you are sincerely listening and taking notes. Okay, so tomorrow I will push out most of the stuff to the repository, okay, to GitHub, and then you can actually download this and then walk through most of them, and then I'll keep it brief every fifth day. Okay, I will push out all the codes, or I will push it every as soon as the class is done. Better, all right, so that you will not forget. I'm really sorry I kept it for so long. So every day, as soon as the class is done, I'll push it, I'll commit it to GitHub. So you just have to get a copy of it from there. Thank you so much, and meet you guys tomorrow. Bye for now.